Hi everyone, welcome to Tech Tutorials 2K21. So today our topic is all pair shortest path using Floyd's algorithm. So here we are going to solve this problem by using dynamic programming approach. So before going to take an explanation of an algorithm and an example, so what do you mean by a all pair shortest path? So now you can see here we have a directed graph. So simply we can say directed and weighted graph because see from each and every edge we have some direction. So and then each and every edge we have some weight on that. So it will show you what will be the distance from one vertex to another vertex and from which vertex to which vertex we can reach directly. So now by using this graph we are trying to find the shortest path. So here we are trying to find all pair shortest path. So now we have to check all the possibilities from one vertex to another vertex. See for example if I want to find the distance from A to B. So either I can take a direct path or I can take an indirect path, right? So that means of that I can make any other vertices as an intermediate. I'm trying to reach from vertex A to B. So now we are finding what will be the minimum distance so that we can reach from that particular node A to B. So this we can uh, go through an example here. So before we solving this, we'll see what is an algorithm. Right, see this is an algorithm for solving this all pair shortest path using Floyd's. So here the Floyd's algorithm will take a weighted adjacency matrix. So first of all we have to construct a weighted uh, adjacency matrix. So for that this Floyd's algorithm will take a adjacency matrix with some weights. So now we have a rows and columns of 1 to n here. So what we are going to do here, we are going to implement a Floyd's algorithm for all pair shortest path problem. So what will be our input? The weighted matrix, right? The weighted adjacency matrix with weights W of a graph with a no negative length cycle. So now we are seeing there is no negative values in your adjacency matrix. And what will be the expected output? So the distance matrix. So now we are finding the distance matrix of the shortest path length. So now the distance matrix will consisting the weights. And these weights it can be overwritten because sometimes we have some path which already existed with some weight that may or may not be a smallest path between that two particular nodes. So because of that reason the weights it may be of overwritten. So now here these I and j loops will run from 1 to n. So which will take the x the row and columns values. From that this k is used for intermediate vertices, right? See I already said like we are trying to take some vertex as an intermediate and we are trying to find whether there exists any smallest path. So because of that we need to take an intermediate vertices by this k loop, right? So now distance of ij that equals to we have to find the minimum of d of ij is nothing but the direct path existed from one vertex to another vertex. So this is a direct path existed and then here it is an intermediate path. So that can from I to k and from k to j. So now we are finding these two distances. If which distance is minimum, so we consider as that distance in your distance matrix. So now we can return that distance matrix which will gives you the all shortest path for this graph. So we'll go through an example. So this is a graph given for you. So now we have to find an adjacency matrix for this graph first. Right? So now that matrix will consisting all the distances between the vertices. So how we have to construct this adjacency matrix? So first of all, we write down the vertices A, B, C, D and A, B, C, D. So now we have to find there is an edge from A to B or A to C or A to D or A to A. Remember, for a particular vertex, now you are trying to find the distance between that vertex, that always it is 0. So because of that reason, we can take A to A, the distance is 0, B to B, the distance is 0, C to C, the distance is 0 and D to D, the distance is 0. So now you are trying to find this uh, adjacency matrix, the weighted matrix. So if there exists any path between the two nodes, we can give that weight directly in that location, or else you can take it as infinite. See, for example, so here I am trying to find a path from A to B, but I didn't have any path. So simply I can take this position as an infinite. And then from A to C I have a path with weight 3. A to D I didn't have any path, so simply I can take this value as infinite. From B to A I have a path with weight 2. B to C I didn't have any path, so I'll take it as infinite. From B to D again I didn't have any path, so I'll take it as also infinite. And then from C to A I didn't have any path, so this is also infinite. From C to B I have a path with weight 7. And then C to D I have a path with weight 1. D to A with weight 6. D to B I didn't have any path. D to C I didn't have any path. So this is the adjacency matrix with weights. So you consider, here we are considering the distances. So now the first one will make it as D of 0. So what it indicates means it takes the length of shortest path with no intermediate vertices. That is simply we can take the weighted matrix. So this is simply a weighted matrix because we are not making anything as an intermediate here. So because the length is 0 here. So by using this weighted matrix, now we are trying to find D of 1. The means of that we want to make length of the shortest paths with an intermediate vertices. It's numbered, it's not more than 1. Right, so that is, so here we have to make a vertex as an intermediate, right? So because you are making a vertex as an intermediate, you have to keep a row and a column as an intermediate. Okay, so you have to take like this. So a row and a column as an intermediate. So now you are making a as an intermediate. Now you are trying to find the paths. So from A to B, A to C and A to D. Right, see here simply is nothing but from a particular node to another node. So by making as A as an intermediate, whether you can reach or not. If you reach with a minimum weight than this weighted, then you have to overwrite that weight with the newly updated value. So now simply you can write the rows and columns of A directly. Right, so that will be of can take A, B, C, D and here also A, B, C, D. So now I'll make 0, 2, infinite and 6 and here it is infinite, 3 and infinite. Right, so these A row and A column is common, so you have to make this A as an intermediate here. Right, simply here I written A as intermediate. Right, now you are making A as intermediate. So now you can keep the values B to B and C to C and D to D is 0. Okay, you keep as usual. Now you have to find the remaining things. See here from B to C I didn't have any direct path. Because of that, in my previous matrix, I have the path distance is infinite. Now I'm trying to find from B to C if I have any path with A. Right? See what I'm trying to do? Now I'm trying to find a path from B to C with A as an intermediate. So this is my B, right? So now this is my C. So now I have a path. See here, from B to A I have a path, from A to C I have a path. So now I can reach B to C with A as an intermediate. So what will be the weights? So here this is an intermediate. So your algorithm will say you can take IK and then kj. Right, now you are trying to reach from I to j by making k as an intermediate. So what will be the weight of this? 2 plus 3, it will become 5. Right, 2 plus 3, the value is become 5. So now you are trying to find a path from B to D with A. So this is my B and this is my D. So I can make A as an intermediate, but I didn't reach to D from B. So simply it will be infinite only. Right. So now we are trying to find a path from C to A. We didn't have any direct path because we are making here A as an intermediate. So directly we didn't have any path. So now from C to B, I'll try to reach from A. So this is my C and this is my B. Right. So now I have a direct path from C to B with weight 7. I have a direct path from C to B with weight 7. And then I am trying to find there is any other path from C to B with A as an intermediate. Now I am finding I didn't have any path from A. So I have to keep this one because it will make min of 7 comma infinite. So which one is minimum? So 7 is minimum. Simply I can take 7 is here. Right, and then I'm trying to find from C to D with A as an intermediate. So now from C to D I have a path with 1. Right, so now you can take min of 1 comma. So did we have any indirect path from C to D with A? No, there is no path. I can't reach with A as an intermediate from C to D. So because of that this will be infinite. So now the minimum value is 1. So simply you can take this value is also 1. And after that now we are trying to find a path from D to A. So we have directly a path with 6. Right. So from D to B. So from D to B. Right. So from D to B. I'm trying to reach with A. So here is my D and here is my B. So I can't reach B directly from D. So what I'm trying to do, if I can move from A to B. So here I didn't have any path. So D to A I have a path, from A to B I didn't have any path. So I can't reach by making A as an intermediate from D to B. Simply it will be a infinite only. Right. And then from D to C. So now I'm trying the path from C to D to C. See, I didn't have any direct path from D to C. Here I'm trying to reach from A. So now we are finding from D to A I have a path and A to C I have a path. So by making A as an intermediate, I can reach from D to C with a weight 6 plus 3 is 9. So now this value is min of infinite comma 9. So the minimum value is 9. Now you can update this value with 9. So this will be our weighted matrix when A as an intermediate. So now you take this matrix for the next step, and there you have to keep two vertices as an intermediate. So here we are making A as an intermediate. In next step we are going to take B as an intermediate, so that this matrix is formed from A. Because of that it will be taken for the next step AB as an intermediate. So now I'll make here from this weighted graph, I'll make B as an intermediate. So I'll keep my B column and B row as common. Right. So now you can take that as D of 2. So what is the mean of this D of 2 is nothing but length of the shortest path with immediate vertices numbered not higher than 3. So that is, we are making here AB as an intermediate. So AB as an intermediate. So again you have to find a weighted matrix. So ABCD, and here also ABCD. Here I have to keep my B column and B row as common. So infinite 0, 7 infinite, and B column is row is nothing but 2, 0, 5 and infinite. Okay. So now you can keep A 0 and CC 0 and DD is also 0. Now you are trying to find the another matrices, right, with AB as an intermediate. So here we are making AB as intermediate. Okay, AB as intermediate. So from this graph. So now see, I'm trying to reach from A to C. I'm trying to reach from A to C. Here I'm trying to reach from A to C. So here I have a path, direct path, that is with weight 3. So now what I'm trying to do, I can reach from A to C with A and B as an intermediate. So I didn't have any path from B. So I can take this as min of direct path is 3 and indirect path is infinite. The minimum value is 3. So I can take this value is also as 3 itself. And then I am trying to reach from A to D. So what your A to D will say? So now I didn't have any direct path from A to D because of that reason. So in my previous weighted graph it is infinite. Right. So now min of infinite. And then now we are trying to reach from A to D with A, B as an intermediate. Right. So A, B as an intermediate, I cannot reach to D. So simply I can take this is also infinite. And then from C to A, right, from C to A, I didn't have any path. Here I am trying to find from C to A if I have any indirect path from B and A as an intermediate. So see here I have a path. So now C to B I have a path, and from B to A I have a path. So I can reach C to A with B and A as an intermediate. So what will be the weight? 7 plus 2. So the previous value is infinite. So it will take min of infinite comma 9. The min value is 9. So simply I can update this value with 9. So now I am trying to find from C to D. Right. So from C to D I have a path directly which is existed with 1. So this is a direct path. So now I am trying to find with AB as an intermediate, can I reach from C to D with less than this weight. So now I can't reach with either A or B as an intermediate. So I can't reach from C to D. Simply I can take this value as infinite because of, so it is 1 only. Okay, and now here I am trying to find a path from D to A. So I already have a path from D to A with a cost of 6. Again I am trying to find with B, can I reach D to A. So now I can't reach. So now this value will be taken as 6 and infinite. The min of 6 and infinite will be of 6 only. So now this value is 6 only. And after that D to C I am trying to find a path. So there is no path is existed directly. So that will be taken as an infinite. And after that, I can reach from D to C with AB as an intermediate. See, AB as an intermediate, I cannot reach this particular C. Right. So from D to C, I cannot reach with AB, BA as an intermediate. But I have a path from A to C. So from D, I can make A as an intermediate. I can reach C with a weight of 6 plus 3 is 9. So simply I can take the same value. Right. So this is when AB as an intermediate. This is your weighted graph. Okay. So now we'll find the next distance matrix. So that is D of 3. So here we are making 3 vertices as an intermediate. So because this weighted matrix is coming from 2 vertices as intermediate. So now we are taking this graph, this matrix as a consideration for finding the weighted matrix in my next step. So now here I'll make C row and C column as an intermediate. It means of that I will take A, B, C as intermediate. ABC as intermediate. So what your distance of 3 will say? So length of the shortest path with intermediate vertices number not higher than 3. So here we have take only 3. So now C as a common, you can make all your C row and column are similar. So like 9, 7, 0 and 1, and this one is 3, 5, 0 and 9. Okay, so you can keep values like A, B, B and D, D is 0. So now we are trying to find the remaining reachability of vertices. Like from A to B, I am trying to reach from A to B with C as an intermediate. See here, with ABC as an intermediate, I can reach from A to B, yes. Because see here I have a path. From A to C I have a path, and from C to B I have a path. By making the C as an intermediate, I can reach from A to B with a weight 3 plus 7, 10. So previously, what is this value? This is infinite. So min of infinite and 10, the value is 10 is minimum. Right? The value 10 is minimum. Simply I can take this value as 10. And after that from A to D. A to D. So I can reach A to D, right, with C as an intermediate. See here, A to D. So with a weight 3 plus 1, 4. So previously it is infinite. So now it is 4. And after that from B to A, so I have a direct path with weight 2. So I am trying to find if I have any other path with C as an intermediate with a minimum cost. No, I didn't have. So simply I can take this as 2. And after that I am trying to find a path from B to D with ABC as an intermediate. So this is B to D. I can go with A and C as an intermediate. See here what will be the weights? 2 plus 3 plus 1. So now 3 vertices as intermediate. So this weight is 6. Right? So this weight is 6. So simply it is 6. And after that from D to A. So here from D to A I have a direct path 6. So now I am trying to find if any other path which is less than 6. So no, there is any other path with ABC as an intermediate from D to A. Simply I can take this value as 6 itself. And after that I am trying to find a path from D to B with ABC as an intermediate. See here. So now A, C as an intermediate, I can move from D to B with a weight 6 plus 3 plus 7. So 6 plus 3 plus 7. So 9 plus 7 is nothing but 16. Right? So this is a weighted graph after ABC as an intermediate. So now we have to find the next distance matrix. So this is A, B, C, D, and here also we can take A, B, C, D. So from this weighted graph, we'll make D column and D row as intermediate. So what this will say? So now you are making, so D of 4 is nothing but it's a length of shortest path with intermediate vertices. It's numbered, it's not higher than 4. Right? Simply it will take A, B, C, D as an intermediate. A, B, C, D as an intermediate. Right? So now I can keep common as D row with D column 4, 6 and 1. So I can keep the values A is 0 and BB is also 0 and CC is 0. So I'll try to find the remaining paths. So now I'm trying to reach from A to B. So A to B I'm trying to reach. I didn't have any direct path. So that path is infinite. So I can reach C, A to B I can reach with C. So this is 3 plus 7, 10. So simply I can take this value as 10. And after from A to C, so I have a direct path with 3. So I didn't have any paths that can be existed from A to C with another path. See here A to C. So I cannot reach any other path. So simply I can take this value as 3 itself. And now from B to C. So now from B to C, I didn't have any paths directly, but I have a path from A to C here. So I didn't have any path from D, right? So I can take this path 2 plus 3, that equals to 5. Sorry, I can't make this one right. So this is 3. And now this is 5. So now from B to A. So B to A, I have a direct path with weight 2. Simply I can take that value. And after that, C to A. So now I'm trying to reach from C to A. I didn't have any direct path. So that path is infinite. So I'm trying to reach any other path. See here, I have the different paths. Like from C to A, I can reach B to A. I can also reach D to A. Right? I have two paths are existed here. So this weight is 9. 7 plus 2 is 9. And this weight is 1 plus 6 is 7. So what will be the minimum thing? Infinite, 7 and 9. The minimum is 7. So I consider as that weight. C to A, the weight is 7. And after that C to B, I have a direct path with 7. So I have an indirect path also, and that weight is 2 plus 3, 5. 5 plus 7 is 12. So the minimum is 7. So I can keep that value is 7. So this is your solution. Right? So now this weighted graph will say from one vertex to another vertex, what will be the shortest path. Right? Now we are finding the shortest path from A to B. The minimum weight is 10. Right? The minimum distance is 10. So, and the time complexity of this all pair shortest path uh, by Floyd's algorithm using this dynamic programming approach is order of n cube.